so you can kind of see it. Now, the homework's going to be based on derivatives, obviously. So there's going to be 3 problems I want to go through. The shortcut is one of the 3. Now, one of your problems, they're going to give you a graph. It'll be something kind of like this, like we talked about yesterday. And they're going to have, an A, B, C, and D kind of a thing. And A, B, C, and D. And they're going to ask you which slope is probably the largest number. So like f prime of A, f prime of B, f prime of C, or f prime of D. Now, they might actually give you numbers. It's the same idea. So when you look at all 4 of these, do we understand that they are different numbers?
Yep.
Okay. This is the instantaneous, rate of change at these numbers. So this would be letter A's slope. That tangent line, it's got a certain slope. B's got its certain slope. C has got its, and then D has that type of slope. Okay? And they want you to put it least to greatest. So what slope is technically the bigger number out of the 4?
A.
A. Why? Why is this a bigger number than the others?
It's more slanted.
It's more slanted. Because if you think about this slope could be half, like rise 1, run 2, rise 1, run 2. But the next slope is tilted more, so the bottom number would have to be bigger. It's going up, but it's running further because it's more slanted. It's actually, the bottom number is getting larger and larger and larger as you go because it's running more, it's getting more flattened. It's nearly turned out to be 0 for a slope. It's approaching 0, a horizontal line. Does that make sense how I can look at a graph and see that? I just picked fractions. I'm making these numbers up. This slope could have been
3.
For all I care, it could have been 2/1 or 3/1. It doesn't matter. As long as you understand, as you go to more horizontal, the numbers are getting smaller. And then obviously, if this thing went back down, those would be even smaller numbers because those would be negatives. So that'd be even smaller slope. Okay, does that make sense what they're going to be asking for? That's one of the problems they're going to ask you to list certain slopes in order by least to greatest or greatest to least kind of a thing. But that's the biggest number, that's the smallest number technically for slope. All right, that's the first problem. Second problem they're going to have you do. We did one of those yesterday where they gave you some type of curve, they gave you a point on it.
You can't see that.
Let's call this on a graph. I'm just going to make up something here. Let's say this was point 2, and this point up here was, let's say this is B and this is A, and B is, let's say this is the number 3 here, that type of thing. It's a terrible drawing, but you guys get the idea. And they might ask to name the equation for this particular problem. Because maybe they have this. Maybe they tell you f of 2 is 10, and f prime at 2 is half. Maybe they tell you that type of stuff. And they want an equation that represents it. Well, you have a coordinate. F of 2 of 10, that's your coordinate.
For y.
That's, 10 is your y number. And then this is your slope. So you can go to an equation for that line, which they call the tangent line, where you could do this. Y minus 10, x minus the 2, and then my slope would be half. Right? That's point slope form. That would represent the tangent line. That's this line right here. They could ask you to find the coordinates for each of those. Well, we already have A's. A's coordinate is 2, 10. Maybe that's the number that they told you. B, if I wanted to find 3, just plug 3 in, and it'll tell you. Because if I plug in 3 for that line, it'll tell me the number coming out of it.
9.5. 10.5.
11.
It's up 1 over 2, so if I went up 1 over 2, what is that? If I went up 1 over
411.
2, so something like that. So what is this, 3?
Yeah.
I just said a number.
So
it's half.
Half.
10.5.
Half. And then you're going to have 10, so 10.5 roughly?
Yeah.
What? 10.5, something like that?
Oh yeah.
Yeah. There it is. Not Christmas.
Okay. Does that make sense what we're doing there for that one? If they ask for coordinates, you just plug them into the equation for the line and forgot the coordinates. So that would be 3, 10.5 and 2, 10. All right, that's the second type of problem. Third type of problem is they're gonna ask you to find derivatives. Derivatives of different types of functions. Today, you've earned the right to do the shortcuts.
How do we earn it?
So, by the homework we did last Friday. We went through it. The good news is, I believe no one missed the last question. The last one where you had to do that differential quotient. So you've earned the right to learn the shortcut today. So, here's the type of problem I want to talk about. X to the, I'm going to use that problem we did in that last problem on your homework. It was x to the third plus 4x.
Equals 6. Equals 6.
What? For what?
What's the answer?
Or else you'd be like this.
Page 290.
Yeah,
Or-
Was it f of 6? Maybe that's what
No, I don't know. Am I even looking at the right? Is this what we did Friday?
9.
Oh, my hand.
I can say random numbers.
Yeah, we turned in the thing that we did on Friday. That was the one that we didn't have time for and we were all supposed to turn it into him.
Yeah.
Oh, I didn't think I was here on Friday.
All right.
Oh, I was in here on Friday.
Oh.
Only certain.
So he knows.
He knows.
Yep.
Okay.
I won't.
So when was
So-
Drew doesn't have the right to learn the shortcut.
I'm dressing.
Now, hey, here's the idea. What we were trying to do on this particular problem was find the first derivative for a certain number, like at 3. And you guys did the differential quotient where it was h, so it was the limit as h approaches 0, and we did this part.
Power's gonna go down.
Okay. X plus h. We subtract the original item.
No, the end power's gonna go down 1.
Okay.
On X.
All right. And we get to this, right? And we had to simplify it all. We even did Pascal's triangle like we did yesterday to simplify this thing out. Then you distribute this forward, you distribute the negative sign. We simplified it all the way out. Eventually, it turned out to be, I think, it eventually simplified, and eventually when we plug in the number 3 into this simplified version, it ended up being a 31, okay? Once you finished it all the way out. Now, here's the idea. That took a long time. It was one of those problems you guys were rushing through, some people were getting stressed out about.
like 4 minutes.
There is a
too.
shortcut. It is called the power rule. Okay? It deals with simple polynomials, simple, mind you, polynomials.
Simple.
And here's the idea. When you want to find the first derivative, and this is my original f of x, instead of doing the actual limit formula, the differential quotient, okay? Here's the trick. It uses powers, but it has to be a normal polynomial. If it's a fraction or anything weird like a natural log or a log, we have different properties for that. There's different things. This is a shortcut for the power rule. So what you're allowed to do is drop the main power out front and you subtract 1 off the power. So that 3 drops out front, we subtract 1 off the power. For the next one, we drop the 1 out front for the x, and then you subtract 1 off of it. You always subtract 1 off the power after you dropped it out front. So in my case, this ends up being 3x squared and a 4, and there's no x on it because it's literally x to the 0. So the x would drop out because x to the 0 is just technically a 1. That's the first derivative. That's what this would actually give you. I know that seems crazy. It would actually end up giving you this because when I FOIL this all out, it ends up being an x to the third, 3x squared h, 3x h squared plus h cubed. That's what it gives you when you FOIL that whole thing out. This is a 4x plus 4h minus x cubed minus 4x all over h. You would divide everything by h, and these items dropped out. And I'm left with a 3x squared, 3xh, h squared plus 4 when I divide everything by h. That had an h on it, and anything that has an h would end up being a 0 anyway. And you can see what I'm left with. It works every time for a power.
That's crazy.
But the thing is, it's for simple polynomials, simple things. There's other rules for like crazy fractions and radicals. And what you're allowed to do is, now that we know the first derivative, now you can just plug in the number that I needed to find. The first derivative at 3.
31.
3 squared plus 4, so this turns out to be 9 times 3, which is 27, and we add 4, which is 31, like we said. Does that make sense what we can do? That's the shortcut. Some people have already figured it out. They did enough of these to actually see the shortcut, what was happening every time when you actually do this. But it takes a lot of you have to compare beginning to end. Some people just didn't see that, they just can't connect the dots that way. Now, it technically works for weird stuff. So what I mean by weird, it would actually work for things if you were to do something like this. Let me give you a different style of problem. Let's say I did something like, that's going to seem a little goofy, but let's say we had 2 over x. That isn't a polynomial, but we can actually do it by the normal rules of polynomials. Because I can make it a power, I can make it look like one of those, and then do it just like normal. So I'll move the x to the top, and when I move it to the top, I just make it a negative power. If that makes sense to you. This is the setup. So, because by putting a negative power, it moves to the other side of the fraction bar. It was x to the first on the bottom, right? And then when I do the normal power rule, the power rule is if you followed up there, you drop the power out front, so 2 times the negative 1, then you subtract 1 off the power, and that would be your answer. So this ends up being a negative 2, x to the negative 2, which, that's the first derivative. Okay? That's the little notation, that's the little hash mark. And so if I want to rewrite this, this is what it actually ends up being. Like putting the 2 back to the bottom. So if I want to evaluate at the number 1, f prime at 1, I can just take this problem and plug a 1 in there. So it ends up just being a negative 2. Does that make sense, the concept?
Mm-hmm.
Okay, the reason why I did that is because if I try to do the x plus h thing on this problem, like the whole differential quotient, you have a fraction, and you're putting x plus h on the bottom, and you're trying to factor out h's and stuff so you can divide them out later. It's actually easier doing this by the power rule, like that rule, than doing the whole differential quotient like the real way of doing polynomials. Because it's not even a polynomial in the first place, because it has an x on the bottom. But it's one of those weird things. And again, what this stands for, what a derivative is, it's that slope at that curve at that exact moment. So I can plug in certain numbers. Certain numbers I can't plug in here. I can't plug a 0 into this original problem. Like if you were to graph it, 0 doesn't exist. So it doesn't have a slope there. And it would still not exist even when you take the first derivative. So it's like kind of a weird concept when you start looking at the graphs versus the slopes. Second derivatives, we've talked about. That's something coming up later, where you could do this again. You can just keep doing power after power rule. I can do power rule on that problem one more time. And those mean different things. For right now, we're just talking about first derivative means slope. Means instant rate of change. We have different terms for it. Okay, questions with the shortcut. You can use the shortcut today in your homework.
How about on the test?
There'll be a lot of problems you can use shortcuts, yes. There'll be a problem where you'll have to show the differential quotient. A problem.
You guys got up there.
Question.
What if the x is in the exponent?
X is, okay. On those types of problems where the x is the exponent, because there was one problem like that. I think that we had one of the quiz, right? Where it was something like 3dx. Okay? That was my question. On those types of problems, I would, no joke, I would do that whole thing where I just pick numbers that are really close. So I would just do an estimate, approximate, where I would try if I want to find the first derivative at, let's say, 2, okay? Let's say. I'll pick numbers really close to 2. So I'll pick 2.001, and I'll pick, 1.999, and these will be the 2 numbers I'll plug into here, and I'll just do an average slope between them. Because the average slope would approximate the first derivative if I pick numbers close enough. So these are my 2 x's. So I'll subtract the 2 x's, right? And then I would, for these 2 numbers, I would plug them in here and write down those answers. So the first number I plugged in was 2.001. I plugged that in. And then I plugged in the 1.999. And I would get that answer on the top, get this answer on the bottom, divide. And this will be approximately slope. I wouldn't attempt to do it like this, because we don't have a rule for that yet. And we couldn't do the differential quotient, because we wouldn't be able to plug the x plus h in. So I would just do an approximation. Okay, that's like the average slope, right? Y minus y over x minus x.
Yeah.
You can still do that. You'll probably need to do that, hint hint.
Yeah, that's actually.
Number 9. I know you're doing it. This other book.
Like the enemies of your.
All right, I know the problems. All right, homework's on the board, page 87, it's 9 through 13, 15 through 18, 22, 23, 35 through 37. There's 2 problems I've not discussed yet. That'll be 22 and 23, we might talk about them tomorrow.
Are they pretty
So don't do that?
straightforward though?
No.
Don't do what?
So
We'll
don't
talk
do
about
those
them
ones.
tomorrow. I'm gonna try and see if you can do it.
I'm gonna snap.
We're gonna try
Should.
and
I'm gonna put a pause on
Okay.
that.
All right, but, there you go.
Jacob, don't come prepared
I
to
would
class.
just love to
Let's
do
that
that.
book. You should get my attention.
I would love.
Can I go get my book with
Do they
Sarah?
have-
So I'll give you a pass.
Why?